We're going to continue to work with some more complex functions that require multiple derivative rules. If you haven't done so already, I want you to take a look at this function and just think about what derivative rules we're going to need in this problem. And I'll tell you, we're going to need two derivative rules here. So pause the video for just a moment just to think about it, maybe jot it down in your notes, think about what derivative rules are we going to use. In this problem, the very first thing I see a function of x divided by another function of x. I think this is one of the easier ones to pick out. It looks like a fraction. We are definitely going to need to use the quotient rule in this problem. So we're going to have to use the quotient rule. And then if I look at kind of each part, if I look at, say, the top part and the bottom part of my quotient rule, when I take the derivative of this top part, I've got natural log of 1 plus 3x. That's going to make me require the chain rule. So we're going to have to use the chain rule for this problem too. So this is going to be a quotient rule and a chain rule. So when we're starting with multiple derivative rules, I like to slow this down as much as possible. We're going to start with what's the top part, what's the bottom part. So t in this problem is natural log of 1 plus 3x. b in this problem is x to the fifth. T prime, the derivative of natural log of 1 plus 3x. Here's where we're going to be using the chain rule. This is where the chain rule is going to come into play. Now, if I wanted to go ahead and use the shortcut that we talked about for natural logarithms, I know that that's going to look like u prime divided by u, where again u is the inside function here. So the derivative of 1 plus 3x is going to be 3 divided by u. That's going to be 1 plus 3x. So at this point, we've used our chain rule and we're done with our chain rule in this problem. We're only focused on the quotient rule from here on out. So we've got t, we've got b, we've got t prime, we need b prime. That's just 5x to the fourth using our power rule. So these are some more complex looking functions. I'm going to go ahead and write out my whole quotient rule formula. So if I want to find f prime of x, let's see. That says low d high minus high d low, square the bottom, and away we go. So b, let's start with that. b is x to the fifth. So here we're going to have x to the fifth times t prime. T prime in this problem is 3 over 1 plus 3x. So I have x to the fifth times 3 over 1 plus 3x. There's my t prime. Minus t, so that's going to be natural log of 1 plus 3x. So minus natural log of 1 plus 3x times b prime. Well, b prime in this problem, let's see, this would be 5x to the fourth. So times 5x to the fourth divided by b squared. b squared in this case, that's going to be x to the fifth squared. So here is my derivative. Now this one is pretty ugly to simplify. Sometimes we do end up with these that are just not very nice for us to work with and simplify, but we'll do our best here. If I look at my numerator, I first of all see I've got x to the fifth. Here I've got x to the fourth. I can factor out some powers of x here. So I'm going to factor out x to the fourth. Here, when I multiply, well, let's leave this here now. We'll leave it as x times 3 over 1 plus x minus natural log 1 plus 3x times 5. All of this divided by x to the fifth squared. When I have a power raised to a power, we'll multiply those two powers. So here in this problem, we'll have x to the 10th power. I would, at this point, cancel some powers of x's. So here I can cancel x to the fourth from both my numerator and my denominator. So let's go ahead and do that. So that's going to give me, let's do this. I'm going to multiply x times 3 over 1 plus x. Remember x, I can rewrite x as just x divided by 1. So 3 times x, that would be 3x divided by 1 plus x minus natural log, and actually, I'm going to move the 5 up, minus 5 times natural log of 1 plus 3x. Now we canceled x to the fourth from both of these, so that would leave us with x to the sixth in the denominator, so we should have x to the sixth in the denominator. So this is better. It's still not great. I'm still not really a big fan of this fraction inside of a fraction. So what I'm going to do in my last step here to get rid of it, I'm going to go ahead and multiply my whole numerator. Oops. I'm going to go ahead and multiply my whole numerator and my whole denominator by that 1 plus x. So I'm going to multiply, we'll do it over here, 1 plus x over 1 plus x. Now first, when I take that and multiply it over here with that first term and distribute it, it's going to cancel that 1 plus x, and I'll just be left with 3x minus, here I do need to distribute that to the second term. We want to be careful because that 1 plus 3x is inside of our natural log. So I'm going to write that as 5 times 1 plus x times natural log of 1 plus 3x, all divided by, and then in my denominator, I'll leave that as x to the sixth times 1 plus x. This one, I will say, was really nasty to simplify. Oops. It was not particularly enjoyable to do. We did it, and you can do it, but it's not a particularly nice problem to simplify. If it ends up being something as complicated as this, I am okay with you leaving your answer in this form. I would like you to try and simplify it a little bit, but this one just gets really ugly, so in this case, I wouldn't worry about the simplifying process too much. But if you did want to simplify it, if you did want to kind of make it nicer to work with, this is what our solution will look like.